Hello, welcome back. In this video, we're going to take a look at the derivative of a to the x. Now, we are going to prove this, so bear with it for just a little bit. So, let's review the derivative of e to the x. We know that the derivative of e to the x is just e to the x. That was our lesson the other day. But we didn't talk about why that is. So let's take a look here. Let's say we're saying y is equal to e to the x. If I want to take the derivative of this, I can use my inverse properties. This is saying that the natural log of y is equal to x. When I now take the derivative, be careful, the derivative of y we know is 1 over y dy dx, and that's going to equal 1. And if I solve it, therefore we can say that dy dx is just equal to y. Well, what is y equal to? It's just e to the x. So we get dy dx equals, well, my y is just e to the x, and that is actually how we get the derivative of e to the x. It just becomes its own derivative. Now, likewise, let's take a look at a different base right here. So let's say we're talking about a to the x. Well, if I say y equals a to the x, this is telling us that the log base a of y is equal to x. I'm going to use my change of base. This is now saying the natural log of y over the natural log of a is equal to x. Be careful, natural log of a is just a coefficient. So this is like saying 1 over natural log of a times the natural log of y equals x. Taking the derivative, I can multiply both taking the derivative. We're going to get 1 over natural log of a, 1 over y, dy dx equals to 1. And I can just multiply now. dy dx is equal to y times the natural log of a. Well, what was y equal to? If I go back here, it's equal to a to the x. So we're going to get a to the x times the natural log of a. And there's our derivative of a to the x. Now notice, in both cases, we get the exponential back. But over here, we're going to multiply this by the natural log of a. That also works here. This is a common base. This is a base of a log. It's just that now I will be multiplying by the natural log of e. In this case right here, my base a would be e. This would be an e. I will be multiplying by the natural log of e, which is just 1. So we don't normally worry about writing it. So that's our rule for today, that the derivative of a to the x is just a to the x times the natural log of a. And again, we can do it generically. We can say it's a to the u times the natural log of a times u prime of x. Don't normally write it this way, but remember, this is just where this comes from is our chain rule. So let's take a look at a few derivatives here. Let's say we have y equals 2 to the x. If I want to find the derivative, dy dx, that's just going to become 2 to the x, my rule, a to the x, times the natural log of the base. Well, the base there is 2, so we just multiply by natural log of 2. And there's our derivative. Likewise, 4 to the x cubed, if I want to find the derivative, we're going to get 4 to the x cubed times the natural log of 4. But there is a chain rule right up here, and the derivative of x cubed is 3x squared. Don't forget the chain part. And there's your derivative. Don't worry about simplifying it. Please don't make that a 12. We can apply our other properties to it as well. For example, for number 3, here we have a product rule. Don't forget our product rule. That's the first times the derivative of the second plus the second times the derivative of the first. So let's go and try it. dy dx. My first is x. The derivative, this is my exponential. And don't forget there is a chain here. We're going to get 6 to the negative x, chain rule times a negative 1. There's a chain right there. Plus the second, 6 to the negative x, times the derivative of the first, which is just 1. And there's my derivative. Don't simplify, just leave it alone. Number 4 here, this is just a chain rule. When we take the derivative, I'll use dy dx, why not? We're going to get 3 to the 4 minus x times, oh no, I messed up here. Nobody reminded me. What did I forget here? I gotta go back. Let me go back and fix this. Woo, thank goodness. Oh, look, I erased it. No evidence. When we take the derivative of the second, see, I just remembered over here, I forgot to multiply that by the natural log of 6. Very easy to forget, obviously, times the negative 1. That's my chain. Plus the second, 6 to the negative x, times the derivative of the first, which is 1. I forgot my natural log. And I remember that when I did it over here. Oh, I got to multiply by the natural log of the base. So very easy to forget, so be careful. Times, but there is a chain right here. I'm going to multiply that by negative 1. And there's our answer. There's our derivative. All right, number 5, quotient rule. Quotient rule, remember, is low, d high, minus high, d low, all over low squared, the bottom squared. So when I take the derivative, f prime of x, low, d high, well, that's my new rule, 2 to the x times natural log of 2. There's a chain rule, but I'm just going to multiply by 1. Don't worry about that. Minus high, 2 to the x, d low, which is our negative sign of x, all over the bottom squared. Cosine squared of x squared. There's a derivative. Don't simplify it at all. All right, go to the next video, and then we'll take a look at the derivative of the log function. That's going to be a fun one for us.